Hello everyone, thanks for joining for the webinar. Before I start with the technical part, a quick introduction about TechScalable. We provide training and consulting services across cloud, DevOps, machine learning, data science, and artificial intelligence. My name is Shivam Sharma. I'm a co-founder at TechScalable. Along with Kopal and Mamta, they both are on the call right now. Microsoft Azure is one of my primary cloud. I have been working on Azure since the very starting itself. And I'm also a certified trainer from Microsoft. My expertise lies in cloud, AI, and machine learning. So today we are here for understanding the fundamentals of Azure, and I will help you understand the learning path as well. To start your journey with the cloud platform, you need to understand the fundamentals of the cloud. Now AZ900 certification focuses on that, so you can go for it. In case you are looking for data fundamentals or data platform is something which is of interest to you, you can go for DP900. And those who want to get started with the AI part can focus on AI900. Once you have done it, the second step for those who want to get started with the cloud platform will be either you go for AZ104, that's for administrators, or you can also go for 204, that's for developers. And once you have done that, your next logical step can be the expert level certifications which are there, 303, 304 and AZ400. Apart from that, we also have more focused certifications on data scientist on Azure called as DP100, AI engineer AI100, data engineer DP200 201, and data analyst DA100. So TechScalable provides training on all of them, and you can join us on LinkedIn or you can follow us on LinkedIn, so you will be in touch whenever we are conducting the batches or webinars around them. So hang in for that information. Today we are here to understand the fundamentals of Azure, and in next 2 hours I will go through the majority of the topics which you need to understand if you're moving to the cloud, or even if you're targeting the certification, then we will be focusing on the majority of the topics, but obviously we cannot cover everything in 2 hours, so I'll try to do my best over there. The session today or the free course that we are providing, both of them will help you clear AZ900 certification. And if you are here for the knowledge part, we will build you the fundamental level knowledge which is required to get started with the cloud platform and make that transition into the cloud. So in case you want to learn the cloud platform or you want to get the certification, in both of the cases, these are the 5 sections over here that if you focus on, you will be able to make that jump into the cloud. The very first thing is you need to understand the fundamentals of Azure platform, like what are resource groups, what are subscriptions, what are regions, what are region pairs. So today we will be talking about most of them. Once you have understood the fundamentals of Azure, you can go for exploring Azure services, where you have to jump a little more deeper into storage services, networking services, AI services, app services, and so on and so forth. Security is pretty important. You need to understand the services which Azure provides for securing your network, for securing your databases, and for overall security. How do you do that? What are the various services and technologies that we provide? The next section that you need to focus on will be of authentication, authorization. So how do you connect with the Azure Active Directory? How do we give access to someone? What is the meaning of governance in Azure? And what are the various compliance standards that are followed? The 5th section that you need to focus on will be the pricing part and Azure support plans. So this is something which is very important in case you are doing a migration to the cloud. Maybe you want to understand, should we go for Azure or AWS or Google Cloud Platform? So the very first thing will be total cost of ownership. So that TCO calculation will be there, and based on it you will decide which cloud will be most profitable to you. And then the migration phases, and with the pricing calculator, how much price that cloud will how much price you will incur if you move your solution to that cloud itself. So all this you need to understand as part of the fifth section. Now in case you are staying till the end, we are also providing you the free access of the course. So the course is also having these 5 modules over there, or these 5 sections. Every company wants to be productive. At the same time, the company wants to be as profitable as possible. To do so, they need n number of internal applications. These applications are supposed to be hosted somewhere. To host these applications, you need servers, storage, and network. And you have to take care of the cooling of the data center. You have to make sure that the servers and the storage which you have is also high available. If something goes wrong, your application should be able to have a failover. Maybe it's you can say high availability, or maybe it's a DR solution as such, but everything needs to be managed by the company itself. Now, just by having a data center, it does not become a cloud. So what functionalities do we have in our cloud? We are talking about that, and this is something which is expected from anyone who goes to the cloud platform, like how to differentiate between a data center and a cloud itself. So one of the core functionalities or one of the core features of cloud platform will be that in cloud virtualization happens. So all the servers, all the resources, everything together will be virtualized, and you or the customer or the tenants over there, they see all these resources as one single unit, and you can provision resources as per your requirement. You can deprovision resources whenever you don't require that. Clouds make deployments very fast, so you can deploy your applications pretty fast, and once you have deployed your applications, you can also scale your applications as per requirement. You can also have auto scaling over there. You can as well as manual scaling in place, so you can scale out and scale in. This is also another functionalities which all the cloud provides. Doesn't have to be Azure, can be AWS or GCP or any other cloud vendor as well. And one of the functionality with the cloud is also having is that in case something goes wrong behind the scenes, so let's say there is a server rack or the server went down, then the application will move to another healthy host automatically. There is no you can say everything will be automated, and there is no human intervention over there. Things move very smoothly. Now when we talk about cloud, there are 3 types of clouds in existence, or you need to understand the cloud from 3 points of view. The first point of view will be that we have public cloud in place, and whenever someone talks about cloud, they most of the time they have public cloud in mind. They're either talking about Azure or AWS or GCP. So public cloud is basically there is a cloud service provider, and they will be managing the data center. They will manage all the services. They will provide it to you, and you will access those services over internet, and you will deploy your resources and everything over there. Second type of service which second type of service or second type of cloud which exists will be a private cloud. In a private cloud, you are responsible for the hardware, the networking, compute, power, providing all the automation, orchestration. Everything is responsibility of the company itself, and that's something, or you can say that's the second type of cloud which can be there. And the type of cloud which is most popular these days will be hybrid cloud, where the companies, they do not deprecate their on-premise investment. They still have it, but whenever they require extra resources, they just burst out to the cloud platform, and they create those as extra applications over there, or they create those any scenario where they need more compute, they can do that. So hybrid cloud is the combination of public cloud and private cloud, and this is something which is pretty generic, and most of the companies, they have that in place like that. So in case you guys have any question till now, do let me know. So now we will be jumping little more in depth now, and we will talk about basically the type of cloud services. Now these 3 things you must have or might have heard before, or in case you want to go for any cloud platform, they remain common. We have infrastructure as service, there is platform as service, and the third one is software as a service, right? 3 type of services are there, and all the solutions which any cloud provides will be bifurcated in at least these three common sections as such. Apart from them, we may also have serverless in place and couple of more type of things now. So what do we have to understand is the responsibility model which is there. Some things you manage, some things cloud provider manage. So if I have to manage my private cloud on premises, basically I have to manage everything myself. We have to talk about storage, we have to manage networking infrastructure, compute needs to be managed, virtual machine, operating system, runtime, application, data and access. This happens when you go for on-premises. You don't go for cloud, you have on-prem private cloud. As soon as you jump into the cloud platform, we have infrastructure as service for you. And now the underlying hardware, the network and the compute part is the responsibility of the cloud service provider. You don't have to worry about that. So there is no hardware refresh cycle. You don't have to worry about hardware getting, you can say, a better hardware in existence today. That is something which Microsoft or other cloud service provider will keep on updating their backend as such. And you will be having full control from the virtual machine point of view, or I can say from the point of view of operating system, any runtime, application, data and access which is there. So that is something which we have full control on. After that, when we talk about platform as service, the next type of the responsibility over here is mostly on the cloud service provider. And this is where we start getting true cloud adoption, or you can say we get more productive because we don't have to worry about the underlying infrastructure and we can simply deploy our applications, and we just have to worry about who can access that, how do we authenticate it, and what mechanisms are there. Now, software as services, when you offload everything to the third-party service provider. For example, one of the most popular software as service solution will be Office 365. You don't have to configure any backend. You don't have to worry about any auto scaling. You don't have to worry about any high availability over there or anything. If something goes wrong, no failover needs to be done from our end. Everything will be done by Microsoft as such in that point. So software as services, where all the management is on the cloud resource provider, and we just manage who access what. If you have a file, then how many people have access to it, and how do we revoke access or grant access, and so on and so forth. Now we will be talking about, so this is you can say the basics of cloud or any cloud itself. Now we are jumping into Microsoft Azure basics. So till now it was generic across all the clouds. Now let's talk about specific cloud services from your certifications point of view or from your knowledge point of view. We will talk about, so these 5 things we will talk about first, and you also need to know them if you want to learn Azure. These are the fundamentals over there in Azure platform. So we will talk about subscription, we will talk about resource group, we will talk about resources, regions, region pair, availability zones, management groups. These 6 basic fundamentals are there to get you started on the Azure cloud. Now I don't do death by slide. That's not how I basically work. So I will explain all these things in the whiteboard, and we'll try to be as interactive as possible, and everything should be making sense to you as well. And once we have finished this, we will go to the next section which is there. We will explore more of services. So I'll use a whiteboard now, and I'll explain all the fundamentals of Azure. How do they come together, right? So check this out. So on day number 1, let's start from day number 1. How does things happen over there? So let's say that's you or that's me maybe, and we want to use Azure. So the very first thing you need the Azure subscription. So how many type of subscriptions are there? There are, to be honest, there are multiple n number of subscriptions available, but some of the ones which you need to understand will be EA subscription, Enterprise Agreement subscription. And for example, the one which I am using right now is called as MSDN subscription. And we also have free subscriptions. We have sponsorships subscription, student subscriptions. We have Visual Studio Enterprise subscription. Doesn't matter which type of subscription, basics remain same. So let's say on day number 1, you went and you purchased any type of subscription which is there, right? Then what will happen for you? There will be one Azure Active Directory will be there. So this is Azure AD, right? This Active Directory will be attached to the subscription, or there will be one subscription which is attached to the Active Directory. We can put it in anywhere around on day number 1. So this box which you see, that's your subscription coming up, that one. And this is where we have Azure AD. Azure AD is identity and access management. With this, you authenticate and you authorize and you log in and you basically do role-based access control with it. So this is day number 1, guys, right? Now what are we doing? Even your account on day number 1, even your account will be there. This is you as such. You will not be doing everything in your company yourself. Obviously, you will hire more people. So these are other colleagues which you have. So these are other people in the company who have joined later on, and all their username and password you have created into Azure AD. Now Azure Active Directory is also called as tenant as such, like that, tenant, like this. So if somebody says that we want a tenant, technically they are talking about Azure Active Directory, right? Now a couple of things I want to clarify over here, and do let me know if I'm going very fast or if I'm going very slow. Then do let me know. I'll change my pace accordingly as well. But couple of things I want to clarify over here is that one Active Directory can be having 2 subscriptions over there. That's totally fine, right? You can have 2 subscriptions. That's not an issue. But at the same time, one subscription cannot trust 2 Active Directory. This is not possible. So at one point in time, it will only have trust of one subscription, of one Active Directory or one tenant, like that. But does this means I cannot make more Active Directory? No, it doesn't mean that. We can create more AD, but we cannot make the subscription trust to AD at the same time. So if I do this, something like that, this will not work out, right? That's not possible by design like that. So you can have one AD, multiple subscription, but one subscription at one point in time will only focus or will only trust one tenant, like that. So imagine you got it, you have one AD with you and you have the Azure subscription. Then how do you start with Azure? Like on day number 1, what's the first thing which you do? The very first thing you need to do is you create a resource group. So this is RG. Now just technically, if I explain that, resource group is just like a logical box. There is nothing, it's not a boundary of any sort. It just logically puts my resources together. So I may be having project 1 resources, project 2 resources, project 3 resources, and so on and so forth. So it keeps resources as such. That's how the name, that's what the name suggests, resource group. So imagine this is where I have some web server. I have a database also over here, and that's a website I have in this project. Maybe there is another database over there, and maybe I have another web server because of some reason here, and so on and so forth. So collection of resources. Now, if I explain you the details over there, in one, so see, resource group is logical boundary. It doesn't stop you from creating resources anywhere in the world. So what do I mean as such? Now in Azure, we have regions of Azure. We have 60 plus regions are there in Azure, and they are spread across at least 140 countries as such. So for example, I have this machine in East US. So resource group is a logical thing. So that is East US, and this might be South India. So where is the resource actually created? Resource is actually created in East US data center of Microsoft Azure, and the other one database I am creating in another box over there, something like that. So what you need to remember is resource group is a logical box. It doesn't stop you from doing any type of deployment. You can have resources which are globally distributed, part of the same resource group. So why do we have it? Like logically, why do we have it? One of the most important thing which with the help of resource group which we do is, for example, this is team A over here, right? You might have heard about a word called as role-based access control. Role-based access control means that based on the job profile, we will give people access as such. And we will not be giving them unnecessary access. We will give them minimum required access to do their working. So when you give access to this team A, right, you can give access on subscription level. That's one of the higher level access, I can say, not the highest, but you can give people access on the subscription. We recommend, or Microsoft recommend, giving access to people on the resource group as such. This is RG level access, like this. We can also give access to people on the resource level, like that. You can say the most granular will be resource level. So 3 layer of access is there right now. One of the question that should come to your mind is, what happens if I have more than one subscription? Then what do I do basically with it? Guys, just give me 1 second. Okay, so all good. Check this out. So now what happens if you have more than one subscription? Then how do you basically manage it, right? So how do we manage it? We create management group. That's the name which is there. They could have gone for other names, but that's the name which they took. So this is called as subscription 1 and imagine subscription 2. So and the group of subscription is called as management group. Management group, like that. So what is this management group? That's just like it's gonna be having subscriptions over there. Just FYI, can I have management group under management group? Answer is yeah, you can have it. So there is no limitation as such, you can put it over there. So if I really now explain the access part which we were talking about before, I can give access to people on management group over here. If I do that, this is the highest level of access which I can give to somebody, and that person will get access on both the subscription 1 and subscription 2 in that point in time. So you can give access over here. You can give access to people on subscription level. You can give access to people on the RG level, resource group level, like this. So like that, or you can give access to people on resource level, like that, this part. So 4 level of access will be there. As part of Azure fundamentals, this is something which we need to understand or think about. Any question which comes to mind, do let me know, and we will jump little more in the regions and the region pairs over there. All good till now? Let me know. Okay, so I think that's all good. Now notice this. So you were saying that. Now there is another very important thing which as fundamentals of Azure you need to understand, that is called as availability zones and basically region pair, right? So let me put that through. So imagine that's where you are, right? And you basically are deploying some front-end instances. So this is where I have maybe this is one web server over here, and that's another web server over here, right? And this is another web server over here. I have 3 web servers with me. Imagine like that, right? 3 of them in my front end, and obviously we will have some sort of load balancer over there, right? So this is that load balancer part, LB part. So traffic might be hitting this load balancer and getting bifurcated over here in these front-end instances. So now this is something which your boss comes and says that you have to provide that. Now how will you deploy this, like, or what options are there in Azure by which we can deploy that? Now when you deploy this infrastructure, or just let me put that in one side. So let's put it like this. So this is something which we want to deploy, right? Now notice this. So this is one region of Azure. How many do I have? I have around 60 plus regions today, and they keep on adding more regions. Now let's say this is East US region of Azure, East US, right? Now just FYI, in every region of Azure, at least the old ones, if you have a data center which was created last year, then maybe they don't have 3 of over there. But let's say East US, there will be 3 data centers in one region, like that. Data center 1, data center 2, data center 3. Now these 3 data centers are called as availability zones as such, AZ, right? So how many AZs do I have in East US? I have 3 of them, AZ1, AZ2, AZ3. What is AZ? AZ is basically availability zone, or if you to understand, you can say that AZ is data center. So we have 3 data centers over there. Now if I want to deploy these 3 machines, imagine this is machine 1, machine 2, machine 3. right? I have 3 machines over there. I want to deploy that. I have 2 options with me which I can do. Either I can deploy all the infrastructure in the same data center, meaning this is my machine 1, that's my machine 2, and that's my machine 3, and this is the load balancer, like that. And that's the traffic coming from outside hitting the load balancer and getting bifurcated like that. What comes to your mind if you see this infrastructure in mind in the screen? Do you think any problem is there in this infrastructure if I deploy this like that in same data center? What may go wrong? What comes to mind? Let me know in the chat window what may go wrong over there if we deploy it like that. Right? So in case the entire, so this is one data center, right? So I think you guys are correct. So in case the data center fails, then all my 3 instances, they fail, right? So that is one thing which may go wrong. So what we can do, why don't we deploy it in 3 data centers? We have 3 of them with us, right? So what you can do, you can put the load. So load balancer is something which can stretch in the region, not just FYI, right? So it stretches inside the region, meaning I'll explain that further, but let me just put the LB somewhere. So this small red thing is that load balancer. I don't have space anymore. So that's my first machine, that's my second machine over here, and this is my third machine over there. So now this load balancer is sending traffic to 3 of the availability zones like that. So traffic which is coming in from outside, that hits and it goes in 3 availability zones or 3 data center. Now in this scenario, if one of the data center goes down because of some reason, my entire solution doesn't go down. This is more high available than the previous one, right? If one goes down, doesn't matter, I still have 2 instances running in 2 data centers like that. So with the help of availability zone, we create regional highly available scenarios. So what is high availability? High availability is basically not having single point of failure. You basically have more than one instance. So if something goes wrong, it will do it will without any downtime. Most of the scenario, we don't even have a downtime, or maybe very less of it, but your continuity of the business will go on from there. So this is called as availability zone, right? That's one of the fundamental thing which you need to understand. Now another thing which you need to understand in case you want to get started with the cloud platform will be what are region pairs. So let me quickly, I think I don't have a picture of it, so let me do the next best thing. Give me a second. I should have put a picture of region pair, but let me show it to you over here. So in Azure, every region is paired with another region. So hopefully you guys can see the screen, and if you can see over here, so we have multiple geographies in Azure, and over here multiple geographies in Azure. So, and for example, in Asia Pacific geography, these 2 regions are there. In Canada geography, we have these 2 regions over there. In US geography, the example which we took, US will be somewhere over here. North America geography, East US and West US. So these regions are paired with each other, right? They are paired with each other. If one of them goes down, doesn't matter. Sorry, so what is the use case over here? Like, what is the meaning of this pairing over here? So let's say you guys have to deploy a sort of failover solution which can have a failover. There is a primary site, there is a secondary site. So it is recommended that in that scenario, your primary should be one of the region pair and the secondary should be the other region pair. The reason being is that Microsoft is bound by SLA. In case of a widespread disaster, they are bound by SLA to bring one of the region pair up. That's the SLA over there. They have to bring it up. So even if a widespread disaster happens, you still will be having like, see, to be honest, East US and West US are more than 300 miles away from each other. That's how by design it is there. It's pretty difficult. It will be pretty the probability of both of them going down because of a widespread disaster will be very less. But still, if it happens, we still have a mechanism by which one of the either primary or secondary of our data center will be up. So whenever we deploy HA solution or whenever we go for BCDR, business continuity disaster recovery, we use this concept of region pair. So just to put it over here, imagine if so by default it's not gonna work like that, but we have to configure it. So this is the second endpoint. So let's say region pair of East US is West US, like that, right? So West US. So if something goes wrong in the first side, we can do a failover over there, and the solution will be, you can say, moved or will be available from the second endpoint. Think it through. Any question which comes to mind, do let me know. Okay, someone is saying, what is availability set? Can you please explain that? So check this out, right? So any other question which comes to mind, guys, before that? So so this is availability zones over here. You are getting this, right? Now I didn't told you, I should have told you before that these availability zones are around 10 miles away from each other. It's actually multiple of 10 miles. Maybe 10 miles someplace, it might be 20 miles away from each other. Some locations might be some extra miles like that, but generally these are 10 miles away from each other, or multiple of 10 miles away from each other. That's the correct word, multiple of 10 miles. And the regions, region pairs are like at least 300 miles away from each other. So they are pretty far away. Now there is one more concept called as availability set concept. Now for AZ 900, that's not really, you can say that's on the higher end, but I'll do my best to explain that, and just hang in with me. So availability zone may be pretty easy, but the next one is slightly tricky one. So check this out. So imagine, so let me give you a scenario as well to think it through. So let's say we didn't have the web server over there. We had some scenario, we had some solution which was syncing with each other. Let me put it like that. Let's say I have maybe three databases are there. One of them is a master copy and other two are slave copy. This is slave and that's also slave, like that, right? Two slaves are there. So there is a sync going on. Now think it through and answer. If I deploy these three databases in this manner, because there are the data centers are at least 10 miles away from each other, then there will be some latency over there, obviously, right? There will be some latency over there. Now your boss may come and say that, see, we want the fastest possible deployment of this mechanism or of this infrastructure which you see in the screen. How will you do it? Then you will go for availability set, or let me put it here. I'll check this out. So then notice this. This is gonna be a little tricky, right? So hang in with me. Notice this. If you hear any background noise, just ignore it, I think. So like that. So that's my first master database. This is my second slave, and that's my third slave. So inter-service synchronization is going on right now. So I have placed them in the same location. But your boss came and said that they still should be high available. Even if something goes wrong over there, it should not crash down. It should be they should run for, you can say, we should provide them with as much high availability as we can. So this is the most interesting concept, guys. So imagine inside that same availability zone or same data center, these are three server racks behind the scenes. So I'm trying to make a server rack, and right like this. So let's say three server racks are there, and these boxes, they represent servers right now, right? Now there is a concept in Azure called as availability set concept. So if I put these three machines in one availability set, right? So this is availability set this time, not zone. So first of all, FYI, availability set is one data center concept or one zone concept. You don't have availability set stretching across zone, right? It's one data center concept. So if you put your three machines in one availability set in that point in time, then what will happen? The three machines will be distributed in three server racks like that. So this is my server rack. Let me put it correctly. This is my server rack 1. That is my server rack 2. That's my server rack 3. So machine number 1 is here like this. Machine number 2 is there, and machine number 3 is there like that. Now why are we putting in three server rack? See, even if one of the server crashes down behind the scenes, doesn't matter. You have two different servers where you can say your two parts of the solution is still up and running like that. Now, when we think about something going wrong, there are two things which can go wrong. One is that the server rack can go wrong. Let's say something went wrong over here and this rack is not available anymore. That's one thing which can go wrong. The technical term of one server rack is called as fault domain. So you see this box over here, this circle which I have. This is called as a fault domain, like that, FD. Why do we call this a fault domain? Like, what is the meaning of it? There is a network switch on the top, like that, and LAN wires are going in the server. If you have seen a rack, generally two LAN wires are there in every going in the every server like that, right? And power supply will be there. This is my power supply to this rack. So if something goes wrong, if the power supply goes wrong, or if the you can say something happens to the network, the entire rack will be down. That's why we call this basically fault domain. Like that is one domain. If something goes wrong, everything will crash. So by putting that availability set, the machines will be in 3 fault domains by default. That's how it will work, like this. Okay, now the second thing which can go wrong is, imagine this guy is Microsoft's engineer, right? And there is a software patch. So he needs to patch his infrastructure. So this guy is not patching your infrastructure, he's patching his infrastructure behind the scenes. So imagine he went and he installed the patch in the underlying infrastructure over there. So he applied this patch over here in this server, not in your machine, in his server. Because of that, if there is a security patch, a restart will be required. If it restarts, your machine will be down, right? So what Microsoft did, very smartly, Microsoft doesn't patch the entire infrastructure in one go. They patch it in a rolling manner, the way we do it in our on-premises as well. So what will they do? They will apply the patch on the first, you see the pink part. That's why I have painted that as pink. You see this pink part. This is called as update domain. So update domain. So this is my first update domain, or 0, like that. This is my second update domain. Update domain. We also call them upgrade domain sometimes, like that. And this is called as third update domain. And there can be 20 to be honest, but I have 3 in the screen right now. So when Microsoft patches the infrastructure, they patch in a rolling manner. They will update the first update domain first. Then they will wait for 30 minutes after that, and then they will apply the patch on the other infrastructure. Then after the successful patching, after 30 minutes, they will apply the patch on the third infrastructure, and so on and so forth. So what will happen if we try to imagine that in any point in time, even because of Microsoft's patching, not more than one machine is not you can say what happens if we patch, underlying infrastructure is not there, it restarts. So my machine is not available. So if I do this in rolling manner, in any point in time, not more than one machine will be down. So that is the first machine down, then after 30 minutes, the second machine may be down, after 30 minutes, the third machine may be down. But in any point in time, I don't have the entire infrastructure down. This is called as availability set concept. It provides local HA solution in the same region. My machines are high available. Think it through. Let me know which part I need to repeat. Okay, so guys, now let's jump into Azure services. And so this works for each availability zone. Yeah. So actually this is a data center level concept. So this will happen in all the, you can say, any data center, any zone as such. AZs are just data centers. Okay, now guys, let's jump into Azure services, right? So this is the first section which you need to understand, that if I take you back to the slide deck, let me just quickly recap it from there. So what have we talked about? We talked about subscription, resource group, resources are there, regions, region pair, availability zone, management group, and extra availability set also, right? So this is the basic understanding of Azure, how Azure ticks. Now, what are we going to do? From your AZ 900 certification or from the fundamentals point of view, we also have to talk about core Azure services. So the most of the questions or the most important services are over here. Some of them, at least 4 of them first, then we'll take more of them. But so we have virtual machines, compute services, we have app services, which is a platform as service solution, we have container instances, we also have Kubernetes in picture. So these are core Azure services, 4 of them. So let's talk about these 4 services and we'll try to understand all the major concepts which are there. And I will just complement this with the next topic, networking, so I can be on time and I can combine a couple of things together as such for you, right? So we'll combine those services with the next topic as well. Let me just open the chat window again. It got minimized. Okay, that's great. Okay, so guys, notice this. Now, whenever in production, everything will be inside network. Network is very important. Network makes that isolation boundary. Networks makes that security boundary. So we can have firewalls in picture. We can have many more type of traffic management concept. So to understand Azure, you have to understand the network. How does it work? So I have this network over here called as East US VNet. Let's say VNet in East US, right? And then this is my subnet, and that's my backend subnet. I made the backend first, and let me just make a middle tier subnet over here. And this is my front end subnet over here. And then I have some more subnets over there. We will use them in a while, right? Some subnets are there. So what are these subnets? First of all, these subnets are just you can say slices of the entire network, because network might be very big in size. So because of that, we will create some small slices of the network as such. So this is my network. It looks like that, right? That's my customers over here. They are sitting like this, like that, right? Now, what are we going to do? Let's put some resources over there. So I have one machine, second machine, third machine. Guys, anyone remember the distance between availability zones? Like for example, if this is my first front end, second front end, third front end, if I deploy that in East US, but in 3 availability zones, what was the distance between them? Anyone remembers that? Some multiple of 10 miles, right? Okay. So, right. So that's that load balancer. That's the multiple of 10 miles. So that's the load balancer over there. And right, and let's make a middle tier as well. So that's my 3 machines over here. Why do we always make 3 machines? Is just like we can say, just to avoid single point of failure, you can have 2 machines also, but we are trying to understand that there are 3 machines as such in every tier, like that. And some maybe load balancing here, but this is a master slave infrastructure, right? Master slave. So how the traffic is coming from outside, and we understand that we have a website over there. So imagine the traffic is HTTPS type, right? So now when we create or when we secure network, firewall comes into picture, right? So this is where I'm creating 2 machines. Check this out in a very weird configuration. These machines are having one NIC card in one subnet, another NIC card in another subnet, one NIC card here, one NIC card there, like that, in this weird manner. And what are we going to do inside this? Inside these machines, we will install firewalls over there. So does these firewalls are from Azure, or can I bring my own firewall? You can bring your own firewall. You can have Barracuda's firewall. You can have any third-party firewall which you want. Any firewall solution, any type of concept which comes to mind. Now, what are we going to do? We will create another load balancer over here. This is LB. Now, just FYI, everything which I am discussing right now is also there in the course which we are providing free of cost. You just have to stay till the end to get the access of it. So even if you don't get it right now, just try to absorb as much as you can, and the rest you can just go through the diagrams again in the recorded version of the training, right? So that's my load balancer. It is having a public IP. So just FYI, in Azure we have public and private IPs. So these blue ones are the private IPs right now. We don't pay for private IP, right? Private IP is free of cost. Public IP is something which we have to pay for. So we try to give them as less as possible. Whenever required, then only we use them. So traffic is coming from outside. It hits this IP over here, and then the traffic goes inside my infrastructure like that. It goes inside, and once it is inside over there, this is why we have those firewalls. This is why we have those intrusion protection systems or intrusion detection system, which will audit my traffic, which will block the malicious traffic, and now non-malicious traffic is going inside my infra like that, right? Then it hits the front end, and then slow you can say behind that it is getting bifurcated further and further, and so on and so forth like that. So first thing is that now just FYI, in case you are new to Azure, the network in Azure is regional concept. What is the meaning of it? Meaning of it is that I cannot have a virtual machine which was in Southeast Asia, part of a network which was in East US. The machine needs to be in East US to be part of East US virtual network. That's the same thing which happens at your house as well. You cannot connect to the LAN wire of somebody else's house by sitting in your house, right? You have the local network over there. So there is no global stretching of VNet over there, but that should come the one concept, or you should ask one question saying that how do we give people access? Imagine this is Southeast Asia. In Southeast Asia, I have another virtual network over there, and this network is also having subnets inside that. This is some machine over there, right? And this machine is also having a private IP address over here, right? This is the private blue color IP. So we want to provide private access from this to that. So how do we do that? We make a peering over there. I think Manish already answered it. That's absolutely correct. So what is this private yellow color box which I have over here? This yellow color part is basically called as peering, virtual network peering. Now FYI, peering, the traffic over peering goes over the backbone network of Azure. So let me just write it down. Peering. And where does the traffic goes over here? It goes over the backbone network. Backbone network like that, right? So traffic will be flowing from that private blue IP address to that private blue IP address over this peering network like that. This is how we connect multiple things together in a infrastructure like that. Now just FYI, one more concept I want to bring it over here is when we talk about networking, another thing which comes to mind is that you always don't have to go for the infrastructure which I created over here. You don't have to go for this VM based infrastructure. We also have firewall which is available as platform as service. In Azure, there is a concept called as Azure Firewall, right? So instead of having any third party, you can go for a managed service. So you can simply deploy this platform as service Azure Firewall, and there is no VM over there anymore, right? So we don't need both of them at the same time. You will either go for the one which I created before, like a VM infrastructure, and just FYI, remember this name. If you deploy the way we did it before, this is called as Network Virtual Appliance. Network Virtual Appliance like that in Azure, right? So something like that. NVA, the short term is NVA, Network Virtual Appliance like that. And if I don't do it like that, I simply make a Azure Firewall, and then the same traffic will hit the Azure Firewall, will get audited, and then will go inside my infrastructure. So either of these two needs to be done. How do you decide what to do? That's not part of this training, but just FYI, we basically do a POC over there to check out the functionality of the customer and do we really need to deploy that or not. Okay, so now when we talk about Azure, we also need to talk about when we talk about network, we need to talk about the hybrid network as such, right? So I'll use the same diagram, so I don't have to make it again, but let's bring your on-premises as well, right? So those who know Azure, guys, what are the three type of hybrid networks which I can create? In the meantime, I'll just make my on-premise box over here. right? Something like, okay, check this out. So something like this, notice this. So for example, I want to create a hybrid network, right? So there are three types of hybrid networks which you can create, hybrid, like that. The first is called as site to site. First is site to site, like that, right? S to S. So this is on-premise site and the Azure is acting like a site right now. So what do? We create a VPN device, because that is your on-premise location. You are responsible for creating that VPN device. No one else will do it for you. You have to make it. This is on-premise, your location. You need to have a public IP there as well. So we are marking all the public with green. So let's put a green IP there, and that's the private IP, your internal ranges. We're not concerned about internal ranges right now, and that's where your on-premise office, everyone is there in the office whenever you go back to office. Now similar thing needs to be done in the cloud. We need to create a VPN device there, but we don't have to make a VM based VPN device. We don't have to make a virtual, you can say, we don't have to make a infrastructure based VPN device. We have, you can say, we have VPN as a service. That's the correct word which I want to use. So this is called as virtual VPN gateway or virtual network private VPN gateway, basically in Azure, like that. So this is also going to have the public IP address, and that's also going to have a private IP, like that. Now what happens? Both of them connects to each other like this. So this connection like that, right? And now the traffic is going something over here. See, check this out. So traffic is going over this connection from on-premise to cloud, like that. It goes in all directions and vice versa. It comes on-premise also. This connection is called as site to site. That's the first type of hybrid connection, site to site. Now in site to site, the traffic is going over internet, but this traffic is going over this VPN connection, like that. So connection is a virtual private network connection, VPN connection, but it's going over internet. So if somebody in the certification, if they ask you what type of hybrid networks can I create, first will be site to site, right? Now what happens if you're working from home? So let's make, this is your laptop, right? And you're working from home right now. So what happens in most of the companies? They make you jump on premise, and then the traffic goes to cloud, like that. Why to do that? We have better ways to reduce the latency as such. So there is another type of connection which you can create directly from your, you can say, from your laptop, which is a point right now. This is point to the site. So second connection is called as point to site, like that. Second type of connectivity. Now in this scenario, we have to install some agent over here. One agent needs to be there, right? Where to get that agent from? We get it from the same configuration. We're not concerned about right now. That is something in case you come for the next webinar, AZ104. I can tell you more about it. We'll make it work. So in this scenario, the laptop, the connection from your point happens to the same gateway over there, and this is called as point to site. Around 10,000 people can work from home using this mechanism, or 10,000 simultaneous point to sites can connect to the same gateway at one point in time. So like that. If I have 20,000 people with me, I need 2 gateways to be there. Then only I can have beyond that. So point to site is the second type of connectivity. Third type of connectivity, guys. This is the one which is where you need. So let's say this is your on-premises again. Why are we making it again? Because we don't have space in the diagram anymore. So that's your on-premises one more time, third time. Third type of network connectivity is called as express route. This is express route as such, right? So what do we do in express route? This is fiber optic line, leash line to cloud, fiber optic line. Now, if you want to have a fiber optic connection to Azure, see, before in all the 2 scenarios, traffic was going over internet, right? But now you are saying that I want a high speed bandwidth connection to the cloud, which is private, which is very secure. I don't want to go over internet. I want high speed, 150 GB per second, and so on and so forth. How do we do it? So you need to involve a third party. To create a fiber optic line to cloud, you cannot go and dig up the roads yourself. Obviously, right? So what do? We involve some third party. So these third-party providers are there in all the countries, right? A lot of names are there. You can just search in your local country and you will find lots and lots of them. Reliance is one of them. Tata Communications is another one. Etisalat in UAE is another one, and so on and so forth. Like there are maybe hundreds more. So what do? These third-party providers, they connect your location to their location over fiber optic line. This is what I'm trying to create, a fiber optic. Their location is connected to the cloud location over fiber optic like this. So you see this gray part. This is express route. The traffic is going over this fiber optic connection. And where does it go to? Nearest Azure data center. From, for example, let's say from Indian geography, I cannot create my connection directly. I cannot have a fiber optic to US geography, right? Doesn't make sense. But we can have to the nearest Azure data center. So this fiber optic will provide me speeds as big as 150 Gbps, like that. It can be less than that as well, and I think 200 Gbps is also out in some of the countries it's supported. It depends on which provider is there. Do they even support it or not? It's possible in some of the countries the fiber optic provider may only give you 50 Gbps. You need to check it out locally, right? Like that. Can we configure this ourselves for a demo purpose? Not really. It will take around 3 months for it to get configured, right? Fiber optic. So that's the third type of connection, like that. S2S, P2S, and express route. So just if you understood what I just explained, if you give the certification, you will get around maybe 100 to 150 marks just in this one screen right now, what we have over there, like peering all together with hybrid connections and some network as such. What comes to mind? Let me know. Are we still going well, or it's becoming very difficult or something? Do let me know about that, right? In case you are new. And just FYI, luckily, if you stay till the end, we will be giving you the access to the course as well, the recorded course. So whatever you are seeing here will be there as well, but it will be slower or more organized, like that, right? We are combining topics together, and those who are not coming will get this as much as you can. Okay, that's great. So okay, now let's understand further. Now couple of more things which you need to understand, or a couple of more questions that will come in your certification if you are planning for for that, or maybe you want to just learn. That's also great. So from both the point of view, you also need to understand how do we secure. I haven't talked much about security in this slide. We have just only seen that firewall is there. That's one thing which comes to mind, right? Firewall, like that, Azure firewall or network virtual appliance. But how do I further secure my infrastructure? There is a very popular thing, or very basic fundamental concept in Azure called as network security group. You see this? So I'm making another box over here. So this is another box over here, and right. Someone is saying, explain this SIEM. Go for the training, right? Go for the course. If we can reach SIEM, I'll explain that, right? SIEM is the last thing as such. Okay, check this out. Now, guys, see, so when we talk about firewall rules, we have source, destination, and so on and so forth. Now, do you think we have any requirement for this traffic to come from outside and hit your inner infrastructure like that? Do you think there is any requirement to bypass the security of firewall of the DMZ zone and directly hit the database or any other layer? What comes to your mind? Do you think there is any reason for us to bypass the security, or that is something pretty bad? We should not do that. No, right? That is something. So the type of answer which we are expecting. Someone is saying we can do that. not a jump box if you're thinking, not a jump box, but generally in normal scenario, we will never ever want to hit the database layer directly. Never ever, right? Never ever. So if we do that, it's gonna be a huge issue. Jump box are different. If in case you are thinking of jump box, that's a different concept. Okay, so how do I block it? How do I tell Azure that Azure, see, block all this traffic? Don't let the traffic come from outside, right? Block it. So I create network security group like this. Network security group like that. So network security group is called as NSG, short form like that, right? What is it? It is just a list of firewall rules as such. Technically, we also call them collection of ACLs, access control list, or you can say in an easier manner, we just call them group of firewall rules. So let's say this is my name of the rule. So rule 1. Let's say rule 1, right? Like that. So let me make a connection like that. And I'll put this arrow again. I'll tell you why. So check this. Rule 1, name of the rule. And what is the source of my okay guys, I want to block traffic coming from outside. What can I put in the source? Think it through. I want traffic coming from outside to be blocked. What can I put? How do I define internet? So let's say port, protocol, and action, right? So one thing which I can do is, I don't want traffic to directly hit my front end like that. It should hit the public IP address of the firewall over there. This front end is having a IP address range of 10.10. Let's say 1.0/24. Don't worry about it. More than this, we won't be discussing. It's not needed for fundamentals of Azure to go in the slash ranges as such, but you need to understand what is NSG. So I made a rule 1. So my source of IP address right now, I can say 0.0.0.0/0. What will happen? This looks like this is internet. Like, how can I define internet? I can say 0.0.0.0/0. Every IP address range IPv4. We can also give IPv6, but that's IPv4 over here. Now destination, I'm gonna put the one which is there, which I wrote very small. So I'm just also trying to read it right now. 1.0/24. Which port, any protocol, deny. Like that, deny. So now traffic and this network security group, once I write, I will apply to the subnet over there. Applying to the subnet is recommended. We do that, right? Like this. So now there is no traffic can come from outside and hit my traffic like that. So the only mechanism for the traffic to be able to come internally will be through the official channel and getting through the firewall layer in the DMZ zone and then coming inside my environment like that. So this is called as NSG, right? Like that. Okay. So, right. So we will be applying NSGs, or you in your production will be applying NSGs on every level like that. Over here, you will apply NSG over there, and so on and so forth, right? So front end rules will be different, middle tier rules will be different, back end rules will be different, and DMZ zone rules will be different, and so on and so forth. So NSGs are always applied in the network. Without that, we will not be having it, and everything will be, you can say, we will block the traffic. And we will only allow, so let me just do it one more time. See, I want, help me out with this guys. So I just want the traffic to flow from, let's say front end to the middle tier. I don't want traffic. I only want this I only want to allow this traffic like that. So what type of rule can I put? I'll make one example of it, right? I only want traffic to be coming from this range into this range like that. So the rule which I create will be having something like this. Let's say rule 2, source of my, let me make a table over here. So let's make a box. That's how it looks, right? So let's make a box over here. And source, let's put it 10.10.1.0/24. That's what we have given, and the destination we are giving is 10.10.2.0/24, like that. And which protocol, which port, you can specify that. So for now I'm just putting some star over there. Let's say port protocol, but I am saying allow, right? This time it is allowed. So traffic will be flowing from that to this. Now if I apply this NSG, but where do I have to apply this network security group? This one will be applied on the middle tier, like that, over here, something like this, right? Can I only have one rule in one NSG? No, you can have hundreds of rules. Maybe this is rule number 2, then rule number 3, and so on and so forth, right? Like that. This is rule 3, rule 4, and all that, something like this. Savio is saying, can we apply NSG only on the subnet level? Not really. There are 2 levels actually. To put that answer, just to give the perspective, you can apply NSG on 2 layers. We recommend, or what Microsoft recommend, or as an architect, what you should do is you should make your infrastructure that network security group is applied on this subnet level. It becomes uniform. Uniformity is there. But in case you want more granular control, what you can do, you can also apply it on the NIC card. So imagine, I don't have space, but imagine this is my NIC card, virtual NIC card, right? So this is the NSG, and this is applied on the NIC card, like that. This is the granular method. So 2 places I can apply, on the subnet level, and I can also apply on the NIC card level. So right. Okay. So let's hit the compute little more. So this is what we have sort of talked about in networking, like network and compute along with it. And now let's hit a little more about the platform as services. So I can tell you more about that. Someone is saying, what did you mention about VNet? NVIC, the diagram, never mind. Okay. So NSG cannot be applied on the VNet, right? NSG is applied on subnet or the NIC card, like that, 2 layers. Okay, check this out. Let's talk about a little more. Let's jump into little more. So till now we were hitting the infrastructure services. Let's go one more step in, right? So this is platform as services and something like that. So when we talk about platform as services, we don't have to manage the infrastructure. So what happens in VM over here? If I want to make a website, I can deploy inside a virtual machine, like that. So what is this? This is called as a virtual machine. This will be having some RAM, maybe let's say 14 GB of RAM, having maybe 8 CPU core, and so on and so forth. So, and that's my website deployed, like this, right? Now I don't want to manage the infrastructure. The next best thing which we can have is we can go for platform as service. Now here behind the scenes there will be some, you can say, virtual machines will be there, but we don't have any control on them. We don't even want control of them. We just want it to be the problem of the cloud service provider. So the OS part over there, the runtime environment behind the scenes and all that cloud service provider will take care of it. And this is our web app. Let's say website or web app. So when you deploy any website as part of Azure platform as services, the first thing which you need to create is a app service plan. This is app service plan, right? Like that. So what is this app service plan? App service plan is equivalent to the RAM or the SKU in a infrastructure as service. So when we were going for IaaS, we had some RAM, CPU, and SSD disk and all that, right? App service plan is equivalent of that, meaning here you can also select how much GB of RAM do you want, what type of compute behind the scenes you want, and so on and so forth. But you don't have to manage the infrastructure. So on a very high level, this is how the platform as service app services will look like. They will be deployed in an app service plan. just one more thing I want to put over here. So it also covers another one of my topic, and databases. Let's bring that in, right? So check this out. So let's say I can make a database in the cloud in a VM over here. So this is called as a this is where we have the database inside the virtual machine, like that, right? So I'm calling this to be SQL server, and I'm calling this to be SQL DB, like that, right? Now hang in, guys, couple of more very interesting concept. So this is infrastructure as service, like that, right? Now when we deploy in a platform as service the same database, now that VM part is not there, but that is VM part is replaced with a thing called as logical SQL server. So this is logical SQL server, like that, right? Something like that. And you just deploy your databases inside that. This is my Azure SQL 1 DB. Maybe this is another database over there. How big, just FYI, what is the big size, what is the biggest size of database I can have as a platform as service as part of Azure SQL? The size will be 100 terabytes. So this is called as Azure SQL, like that, right? Something like this. So the biggest size of one database can be 100 terabytes, like that. So in the certification, if they ask you any limit, the biggest will be 100 TB, like that. And there is a very fancy name we give to this database called as hyperscale database. So this is hyperscale SQL, like that, the one which is 100 terabytes. So now guys, hang in with me. So I can deploy my databases in Azure cloud as infrastructure as service, which we have on the left hand side. We can also deploy the databases in Azure cloud as platform as services, and we don't have to manage the infrastructure over there, right? Infrastructure is managed by the cloud. So do I have to install any OS patch over there? No. Do I have to patch my SQL? No. That's Microsoft will do it. Do I have full control on my database? Yeah. On my database, I can do anything as such. But in the infrastructure, we don't have any control. The third type of offering is the most interesting one. Now there is another offering in Azure called as serverless SQL. Serverless SQL, right? The new one. Check this out. This is the new one, right? I'm pretty positive you guys might have already seen it or used it, but check this out. What happens over here for others? Now in serverless SQL, when you make your SQL database in cloud, just like in platform as service, you don't have to worry about any infrastructure. Obviously, we don't have to, right? But if we think it further, whenever you are running something, there are two types of cost involved. There is a storage cost, right? And there is a compute cost. If you think it through, two types of cost can be there. There can be others also, like bandwidth cost can be there. Yeah, to be honest, there can be multiple more, but on a very higher level, at least these two costs will be there if you run anything: storage cost and compute cost, two types of cost. In serverless solution or in serverless SQL, we always pay for the storage cost, because obviously you cannot delete your data. Microsoft cannot delete your data, right? So storage, you always have to pay for it. So you always pay it. But storage is a very dirt cheap thing. Compute is the expensive one. And compute is something which is very interesting. Notice this. So what do? We specify min-max, like that, min-max, right? And then there is another thing called as pause, right? So let's say pausing functionality. So I'm trying to make a graph now. So this is my, that's the x-axis, and let's say there's the y-axis over here. And basically I'm gonna put time over here, let's say time, and that's where performance, right? So performance, like that. So let's put that here. Now in serverless solution, let's put a bar of maximum resources, let's put a bar of minimum resources, right? Let's put these two bars over there as such. So whenever the request comes, the database will be consuming some resources in between max and min, like that, in any point in time, like that, right? Maximum and minimum. It will scale up, scale down accordingly. But in serverless, there is a very interesting concept called as pausing functionality. So let's say you have given that there is the idle time or pausing is 60 minutes. Imagine, let's put it 60 minutes. So what happens at 3 p.m., right? This is 3 p.m., that's 4 p.m., like that. So from 3 p.m. till 4 p.m., there was no transaction going on. There was no query running. There was nothing happening in the database. It was totally idle. So what will happen if you specify 60 minutes over there, like period of inactivity or pause after how much time? So if you specify something like 60, so if there is a 60 minutes of inactivity over there, the database will become zero. The compute cost will become zero. The resources allocated to the compute will become zero, like that, right? You are not paying anything right now. This is zero cost. Only storage is getting cost, is being charged right now. But what happens if the next query comes? So at, let's say, 4:15, some query came and so on and so forth. Then database will start again. It will become unpaused, and this is again, it started here. And what is a min max? It will again go between min and max, something like that, right? So this is called as serverless SQL, where we have min max functionality. We can pause infrastructure, and this is very dirt cheap. Think it through, what comes to mind. Right, this is something which you just need to have a look at, that in Azure we have three type of solutions. We have your SQL can be in PaaS solution, SQL can be serverless also, SQL can be in VMs, and so on and so forth. There is a question in chat saying what about backup and restore in PaaS solution? Backup and restore in PaaS solution is part of the service itself. There is 7 days of backup, right? 7 days of retention, and 35 days is the maximum over there, like that. Is this even possible in reality to expect this time of pause? Now see guys, it's not. So serverless SQL is not, serverless, just FYI, what is serverless? Serverless means compute on demand. So if you are not using something, why should you pay for it, right? If you're not using something, why should you pay for it? In the previous two solution, you were paying for it. Even if there was no query running against the SQL, you were still paying for the VMs running cost. Even in platform as service, if there is no query running against the SQL over there, you were paying for the logical SQL server running cost over there. But in serverless, if you are not using it, why to pay for it? Now I totally agree with you that not in every scenario it can be implemented, but we have so many LOB applications which are not being used 24/7, right? So in that scenario, even this pause functionality is very useful. Okay. Now, so someone is saying, there's a question in the chat saying, so there is a DB on-prem, can he jump to serverless SQL or he should go for IaaS solution? What will be the best for him? Okay. Now, that is one question I was trying to avoid right now, but because you asked, so check this out. So I didn't want it to complicate it further, but notice it now, right? So just FYI guys, notice this. So I'll just select my IaaS server and let me move it a little more to the left hand side. Okay, come on, move. 1 second, let me just select that again. Yeah, that's good enough. So now what happens when we go to the cloud, guys? So there is a question in the chat saying, what happens if I want to take my SQL from this on-premise location to the cloud, right? Now the question which I will ask you, if I have to do that migration is, what are you looking for exactly? Are you looking for rehosting? Rehosting means whatever I was doing on premises, I want to do the same thing in cloud. So when we talk about migration, one specific scenario guys, migration scenario. So if we talk about that, check this out. You can do so there is a word I'm using, lift and shift, like that. Lift and shift means whatever I was doing on premises, I want to do the same thing in cloud. So I just lift and shift. I rehost. I was running VM here, I will run it there, right? Full compatibility, no error. But if I want to do a lift and shift to platform as service, or if I do a lift and shift to SQL serverless, now there is a lot of rewrite required. Lots and lots of changes will be there. You will not be able to do a migration without changes to these platforms. So what Microsoft did, people were giving feedback. People were saying that, see, if using a VM is not really true adoption of the cloud. The problem is the VM doesn't give the same cost cutting which platform as service can give you or other solutions can give you, right? Like the no management, less management, and so on and so forth. So people were saying that, yeah, we can go for IaaS approach, but can you give us a better approach? So Microsoft took the feedback, and what they did the most confusing thing for you, which is called as managed SQL. They gave a new offering here in middle over here. Now what they did, honestly, behind the scenes we have VMs. This is VM behind the scenes, right? But you don't have to manage it. VMs are totally managed by the cloud platform provider. So this is called as managed SQL, like that. Now in this scenario, I can do my lift and shift to this. So lift and shift, or take whatever I was doing on-prem, do the same thing in the cloud. So what is that? Why was managed instances created? Managed instances will provide you full compatibility with what you were doing on-premise. Same thing in cloud. But just like platform as the service, you do not have to manage the behind the scenes infrastructure. So it reduces your overall cost over there, overall of the everything. So this is the answer for that question, that if I'm doing a migration, I may prefer going for this first, like that. This is, you can say, your starting point can be one step ahead of infrastructure as service as part of managed instances. And if you're developing something new, let's say new application, then in that new application you can go for platform as service. And if you really have that requirement of serverless, you can go for that as well. Something like this. Any question which comes to mind, think it through. Okay, so we have around 30 minutes with us. So I want to go into the big data services, IoT services, big data services, AI services, and so on and so forth. I want to tell you a couple of things over there which you need to understand from the point of view fundamentals of Azure. So if you are targeting the certification in those type of services, what do you need to know, right? I'll give you the overview of that part. So I'll combine a couple of things together and just absorb this. And anyways, you are getting the access of the course, so you can go through it again and again over there. But notice this. So couple of scenarios I want to combine together over here. Notice this. So that's where I have IoT devices. So maybe there is a car, right? Let's say that's the car, and these cars are streaming some data right now. What type of data can they be streaming? They may be streaming some sensor data, vibrations going on, temperature of the engine, how many times you are pressing clutch, how many times you are putting brake, and so on and so forth. So all those data might be getting, you can say, streaming for some further analysis in the cloud. Second thing which you might be doing is you might be having any other scenario, maybe Uber. So that's the Uber application, right? That's where you are pressing right now, book my ride, like that. You want ride like that. So this is Uber applications. So there is IoT scenario and there is event driven scenario. Event driven, like that. So two scenarios I have right now in the screen, something like this, right? So when you click on that Uber application, data is also streaming in this scenario also, right? Data is streaming. We have to do something with the data which is streaming. So the topics which you need to understand, or you don't need to go into depth over here in the fundamentals, but you need to know what's going on, right? So when we have the IoT data, let's say vibrations are going on. To be honest, just FYI, vibrations are of many types.
we have free vibrations. Free vibration means that every material will have a sort of natural free vibration over there. Or to be honest, let me put it like this: that if I hit any material, it will oscillate freely like that. That's a free vibration. We have natural vibration. Like every material will have a different natural vibration. So free vibration, natural vibration, and forced vibration. Forced vibration means that if something is broken, if the material is under stress, then we have forced vibration. So you want to find that out. If there is a maintenance required in that car, or if there is a factory floor and you need maintenance in the conveyor belt, you want to inform the driver over there that something will go wrong because of the forced vibration. So come for a maintenance before the car breaks down. Come for the maintenance because we have detected forced vibration. So something is wrong. So how will you know that? You have to do some analytics on top of it. So what do? We basically may be having some ingestion layer solutions over here. This is from where the topic starts. So in cloud, we create ingestion layer solution first. Ingestion layer. When we have IoT, we have IoT hub over there. Azure IoT hub like this. When we have event driven scenario, we have event hub like that. This is event hub. What are they doing? Like, to be honest, what are they doing? They are just ingesting data. That huge millions and millions of events which are coming, they just ingest it like that. IoT hub is actually bi-directional. You can push some configuration files back. That's one of a very high level difference between IoT and event hub is like IoT hub can be bi-directional also. So data is coming in, right? In a huge stream, data is coming in. Now, when you want to process that data, now this is from where there are multiple things can happen in cloud. One thing which you can do is you can create a big data cluster over there to process the stream of data. So what I want you to remember is that in Azure, when we talk about big data services, there are two services available. One is called as HD Insight, like that. This is something which you should know about for the fundamentals. Second service is called as Azure Databricks. That's the second type of service. Very popular service like that. Big data services. So what will happen even if I do any of one of them, but what will happen? So basically, let's say this is where I have some compute clusters. You see these clusters, these are compute clusters like that. So data is coming from that stream in real time. And this is where I have compute cluster and there is a job. That's the job. Who wrote the job? You might have written it. So what language might be there of this job? Don't worry. You don't have to worry about this in the certification, but just FYI, Python might be there, Scala might be there, PySpark might be there, Spark SQL might be there, and so on and so forth. So some jobs are there. So in this job, what you might be doing? You might be doing an anomaly detection. Anomaly detection will be that from all the data which is coming, I want to figure out the forced vibration. If I can figure out forced vibration, I can notify my customer that come for a maintenance before your engine breaks down, right? Or before you break the transmission over there or something, come for the maintenance. So data is streaming and we are processing and we are writing the output somewhere. So what you can do, you can use visualization services of Azure. Not of Azure, but in Microsoft world, we have Power BI. Power BI can be used for that visualization service over there. Let's say real time. You can also store the outputs. So in case you want some database to be there. Let's say this is where I have SQL database, structured database, same which we talked about previously. So maybe you want to put the flags over there, right? Or you maybe want to go for another type of database called as Cosmos database. So there are more things in cloud. So beyond, I just have 2 hours with me, but there can be more things in the cloud as well, right? So let's say there's a SQL database, right? So whatever forced vibrations which are getting detected right now, we might be, after detection, we might be storing them somewhere. Storing the flags somewhere, like this is Shivam's car, right? So Shivam is the car owner right now, car number some XYZ, and then you might be dropping me a email one day saying that Shivam, your car will break down probably it will break down very soon. So why don't you come for a maintenance? So what do I want you to remember is that in IoT scenarios, IoT Hub is the ingestion layer service. In event-driven scenario, Event Hub is the ingestion layer service, right? And secondly, when we have to process data, there are many ways to process it honestly, but the two type of big data processing solution which I want to tell you will be HD Insight and Databricks, like that. These are the two offerings as such. With that, we will be doing transformations or machine learning or any sort of job on top of that data which is streaming in right now. Now, I just want to show you something. Couple of last things I want to mention over here, and we will be on time as per that. So I was just using some words like AI, machine learning, and so on and so forth. So in Microsoft world, we have, or in Azure world, we have three type of families of solution. First family is called as pre-built AI solution. Second family is called as custom AI solution. The third family is called as conversational AI solution. Let me just quickly go back to my slide deck. That's the right time to get it back. Okay. So check this out, guys. Right. So as part of the AI solutions, we have three types in Azure: pre-built AI, custom AI, and conversational AI. Three solutions like that. Pre-built AI are called as cognitive service, right? Why do we call it pre-built? Because Microsoft already made that and published that as API endpoints, and any developer can use them to integrate in their solution. Just to give you a visualization of that, like what do I mean? I'll just take you to Microsoft's website, and I will just scroll down into the speech over there, and let's say speech to text maybe. Right. See, now if you want to make Alexa, Siri, or anything like that, the first problem which you have is you want to convert the speech into text. Once you have converted the speech into text, you may be having some more commands on top of it, but that's the first problem. So why to create your own solution? We already have this pre-built solution. In the screen you can see that, right? It's converting my speech into text in a real time, and it is doing a good job. It's not trained for my voice, but it's trained for the accent as such, and it's doing a fairly good job. Maybe it's wrong at some places, but still working out. So this is one type of cognitive service. In Azure, we have 28 total. So ready-made solution can be integrated with any product, and the product becomes AI enabled, right? When we cannot do that, when you don't, when the problem statement is something which cognitive service cannot cater to, we basically have custom AI. This is where we have data scientists, and data scientists will be creating some sort of machine learning models which are for your company only, for your problem statement specifically like that. Now, third type of AI service in Azure is in the family of conversational AI, and this is where we create chatbots, right? The chatbot need not always be text oriented. It can be speech oriented as well. It can be visual. It can be some sort of, you can say it can be having picture oriented and so on and so forth. So all those things can be there, right? So this is the third type of AI service called as conversational AI over there. So in case you want to learn more about these, we will be doing pretty soon, we'll be doing some trainings on DP100, which is data scientist on Azure. So you can join us for that, and we'll be going in the technical part of it, like how do we create the algorithms, how do we not create the algorithm, to be honest, how to tune the algorithms, how to select the correct family of algorithm, how do we make the AI solutions, and so on and so forth. But before you can come to that, do take the logical step and learn more about Azure before it. So this is something which I have already covered, and I think this brings me to the end of my the slides which I had for you. There is just one last part which I have for you, which is in part of Azure pricing and support. So if you have to work on Azure or you want to get started, you need to understand the pricing and the support plans over there. So you basically have to learn three things over here: planning and cost management, service level agreements, and Azure support plans. So pricing and cost management will be, let's say, how do we calculate the cost? How do we go to the cloud on day number one? Why do we go to it? Is it gonna give me some benefit or not? If I go for platform as service, how much cost will be there? If I go for infrastructure as service, what's the difference in the cost? So based on that, what service level agreements do I have? For example, uh, if Microsoft says that we will provide you with 99.95% SLA, right? Something like this. Then what is the meaning of that? Like there is a 5 minutes, there can be a 5 minutes of downtime in the entire week. There can be 21 minutes of downtime in the month and 4.38 hours of downtime in the year. If you're going for 99.99, if the service provides you 99.99, then it is basically one minute in the week. And if you are going for 99.999, it is 6 seconds of downtime can be there in week. So we need to understand how to read the SLA. You need to have a look at it, like what's the meaning of it, and so on and so forth. And how do we design composite SLA? So there is a very pretty interesting thing. So imagine you took two services. So service number one, it provides you with 99.95 SLA percentage. And the second service which you had, I'm just putting some numbers for your you can say imagination, 99.99, like that. So if in your solution you have both of them at the same time, your front end is having some 99.95, your back end is having 99.99% SLA, then what is the total SLA? Total SLA is a multiplication of them. You just multiply both of them, whatever output comes out to be, that's your SLA of the solution. So how do I make it? I just have to multiply this with that. So this is how we calculate the composite SLA of our solutions. All these things you need to understand. That's part of the pricing and support in that point in time. Oh, I think somebody already calculated. Thanks for that. So that's what we need to understand.